Each year, many people die in car crashes. Distracted driving, a problem that's been around for a long time, is the third biggest cause of motor vehicle accidents. Although various driver assistance technologies exist, almost none of them directly address distracted driving. I've created an inexpensive distracted driving monitor that alerts drivers when they are distracted and can be clipped to a baseball cap. When drivers are distracted, they tend to move their head away from the road, causing the distance between their head and the windshield to change. My device, DriveAlive, constantly monitors this distance, and when it changes outside a certain tolerance band and the speed of the car is above 15 miles per hour, an alarm goes off, alerting the driver that they are distracted. This minimum speed is so the alarm does not go off when the car is moving slowly or not at all. The main components of my device are an Arduino Nano, an ultrasonic distance sensor, and a GPS module. The ultrasonic distance sensor measures the distance between the driver's head and the windshield, the GPS module checks the speed of the car, and the Arduino board controls all the modules. Now I will demonstrate the prototype. The driver sits down in the car, turns the device on, and then wears the cap. The driver then makes sure that they are sitting normally in the car, then they press the calibrate button on the cap. For this demonstration, I've disabled the minimum speed so it can be seen in action without the car moving. When I look away from the road for more than 3 seconds, the buzzer will be set off. When I look straight again, the buzzer stops. I've given the driver 3 seconds to allow for them to do things like check their blind spot. I tested the device by having the front seat passenger simulate distracted driving while wearing the device. This graph summarizes the results from one of the test runs that I conducted. Each letter corresponds to an event during the test drive. Alarms were triggered during events A, B, G, H, and I when the driver was doing things like texting and eating. Alarms were not triggered during events C, D, E, and J when the driver was doing normal things like checking their blind spot. After conducting these tests, I have proven that this device works as expected most of the time. There's still some room for improvement. In fact, I'm working on a variation that uses a gyroscope to make it even better. My name is Adi, and I hope DriveAlive will be available to the public in the near future.